Welcome to SanfordFlipMath. This is PreCalculus. We are again working from the Demana Waits Foley Kennedy book. We're in the 4th or 5th edition. We are in chapter 4, which is the Trig chapter, focusing specifically on right triangle trig right now. We are continuing our adventure in section 4.2, looking at special right triangles, and mostly this is going to be a review from geometry for this first part. Then we will move into solving right triangles and even, dare I say it, a word problem. So let's get right to it. I need to remind you of the special right triangles, and so this, what you see in front of you right now is obviously not really a right triangle. What I'm actually trying to draw here is an equilateral triangle, and I'm labeling these lengths in a specific way so I can get things to work out a certain way. And what I've done is I have an equilateral triangle, and I've dropped the altitude. This line right here, the altitude, and the reason I'm doing that is because of the symmetry of this particular triangle. Not only does that make a perpendicular line, that's what an altitude does, but it also bisects this angle, and it also does this in such a way that this side is divided in half. And so a lot of cool stuff happens as a result of this. Okay, so for instance, normally in an equilateral triangle, these angles are all 60. And since this top angle is cut in half, these little guys are going to be 30 each. And so what we've just done is basically established, created a 30, 60, 90 triangle. So I'm actually kind of done with that little guy right there. And so I'm going to get rid of it. Goodbye. And in fact, let's do this. And I know you're probably annoyed because you were probably taking notes on that, and I'm sorry. But all I wanted that for was to establish where this came from, and remember that I had this was 2a, and after that little altitude angle bisector median, this was half of that, and here is a 30, 60, 90 triangle. The 90 is kind of redundant since the angles have to add up to 180 anyway. And then just for a second here, I'm going to call this side b, and we're going to solve for what that is. So a squared plus b squared is equal to 2a squared. And I'm just doing this to remind you of all of the ratios for a 30, 60, 90. I know that you'll find this shocking, but sometimes people forget this stuff. So really, this is the square root of 3a squared, which we can do the square root of a squared, and we're left with a square root of 3. So this is, and so we don't really need the b anymore, so I'm going to get rid of it. This is a big deal. And this should be familiar from geometry. And so again, remember that side lengths are in the same order as the angles they are opposite. In other words, if this is the smallest angle, that's the smallest side. So this leg is the shortest side of this triangle, the leg opposite the 30. If you double that leg, you get the hypotenuse. Again, this is specific just for a 30, 60, 90. And if you, the side that's the middle length side happens to be across from the middle size angle. Okay, so I'm just going to make a quick little note over here. So this is a, 2a, a root 3, 30, 60. Okay? All right, so with that in mind, let's do the same kind of thing, only this is an isosceles right triangle. I can spell, trust me. Isosceles right triangle. Okay, so if it's isosceles, then what I mean is that the side lengths, well, first of all, that's a right angle. The two of the sides are the same. Can't be the hypotenuse and a leg that are the same, because the hypotenuse has to go with be across from the largest angle, which is the 90-degree angle. Okay, and then let's do a little Pythagorean theorem here. A squared plus b squared equals c squared. Well, since the legs are the same, and I'm not spending a lot of time on this because this is really geometry, and it was reviewed also in Algebra 2, and here I am reviewing it again. The square root of 2 I can't do without making a mess. Square root of a squared will be a, and so this is a root 2. Okay. Because of these sides being the same, these angles across from them have to be the same, and so they actually have to be 45 degrees each. Okay, so this is also called a 45-45-90 triangle, or 45-45 right triangle, also referred to it as an isosceles right triangle. Okay, okay, let me make a quick note of that guy. Oh, that's not very nice. We want it to at least look fairly isosceles. Yeah, it's better. Okay, so quick little note here that a square root of 2 goes with the 45-45-90. Okay, and what I'd like to do is grab all of that and see if I can group it together. Okay, just want to do a couple of things with this. Let's see if we can do that. And clear ink. And let's see if we can paste that in there. It didn't paste what I wanted. All right, here we are. Okay, so what I need to do here is talk very quickly about sine of 30, cosine of 30, etc. And that's the etc. etc. All right, so we're going to go through the special triangles, and can I just say this is a big deal, and we're going to look at some ways to kind of remember some of this a little more quickly when we get into the next section, but we need to focus on, part of what we need to do is just remember these. 30 degrees, 60 degrees come up a lot, and so does 45 degrees a lot, just because of the way we have our numbering system set up. So we need to just really know these, and it's going to start out by us just kind of working through it, and then the more you see it, the more you'll get comfortable with it. So sine of 30. Now, just a reminder that SOHCAHTOA is one way to keep track of these. So sine is opposite over hypotenuse, so I'm going to go to the 30-degree angle and go across from it is A, and the hypotenuse is 2A, and I can reduce that to 1/2. So the cosecant should be the reciprocal of that, so 2. Okay, I'm going to go slow through some of this, and then I'm going to start boogieing. Cosine is square root of cosine of 30, so that's adjacent over the hypotenuse, which is square root of 3 over 2. Now, if I do the reciprocal of that, and then rationalize, now, if at any point this starts going too fast, just pause, make a note. But all of these values are values that you need to know, and need to be able to get quickly. Now, if you know your 30, 60, 90 triangles, then it goes fairly quickly. But if you don't, then this is going to feel a little overwhelming, probably. But you can do it. You just got to fight through it. Cotangent's reciprocal, so I'm going to flip that first simplified version, and so it's square root of 3 over 1. Okay? All right, so that's everything for 30 degrees. For 60 degrees, it is very, very, very similar. It's just you're starting sine of 60 is 60's here, so opposite over adjacent. These A's are going to cancel out every single time, so actually most people don't even write them. So just, you know, this would be 1. So you can still write them, it's just understand that the A's are going to divide out. Okay, so this is going to end up 2 square root of 3 over 3 after it's rationalized. cosine of 60 is 1/2. Again, adjacent over, that's going to be 2 over 1. And then tangent of 60, square root of 3. And the reciprocal, square root of 3 over 3. Okay, same ideas when we start getting to 45 and sine of 45. So here's 45. Sine would be opposite over adjacent. So this is 1 over the square root of 2, which is square root of 2 over 2. The reciprocal is just square root of 2. And a cosine turns out to be the same exact value, because the adjacent and opposite end up being the same. Tangent of 45 is a over a, which is 1, and the reciprocal of that is 1. Okay. Now again, I kind of went through those quickly, but these are all based on those 3 triangles, which you need to own them. You just need to have it. Okay. All right. We need to spend a little bit of time solving right triangles, and solving right triangles. You may recall when you're solving a triangle, that basically means find everything. Okay, now let me remind you of the standard setup for labeling a right triangle. Generally, the right angle is C, and then the side opposite is little c. Okay, so angles get capital letters. And then side lengths, lowercase. Okay, same letter, same letters opposite each other. If it's a right triangle, the right angle is usually C, and the hypotenuse is usually C. Okay, we'll make that look a little bigger. Okay, and then the other sides and angles are similar, only A and B, usually. Okay, there's nothing sacred about this lettering system. It is just very, very, very common. Okay, so let's just put a little example up here. Oh, that's a beautiful triangle. I can't let that stand, sorry. I know that was like another 3 seconds on the video. All right, so let's just call this A, B, and C. It doesn't matter which one is A and which one is B, just as long as they're labeled opposite each other. Okay. All right, let's put some numbers on here. Let's say this is 20 inches, and let's say this is 70 degrees. Okay. And the instructions would say something clever like, solve the triangle. Yeah, that's pretty much it. Okay, so let's focus on what's easy. In this case, I happen to have one of the angles, and I also know a right angle. So remember, the angles inside a triangle have to add up to 180. So angle A is going to be equal to 180 minus 160, so 20 degrees. Okay, so A is 20 degrees. Okay, we'll just reserve a little spot for the stuff we need to know. I don't know little a, I will in a minute, and I don't know little b, and I will in a minute. Okay? All right, now I know some of you see this and you think law of sines, and you're really overthinking it. I'm working with right triangles, so I can do the right triangle trig ratios. Okay, so at this point, I need to decide what I want to find next. And you can pick. Okay, I already know this is 20, and I know C, so I either need A or B, and I'm just going to pick one. I guess we'll start with side A. And the way I'm going to solve this is I'm going to go back to my original information. Sometimes you can, sometimes you can't. But my original information was this side, which is the hypotenuse. I know this angle, 70, and I'll work with that one. You can do this from 20, but I'm going to do it from 70. And from the 70, this side is adjacent. So now I'm thinking to myself, adjacent and hypotenuse. Adjacent and that's cosine. So cosine of 70 degrees equals adjacent, which I don't know, over hypotenuse, which happens to be 20. Okay, so I'm going to multiply both sides by 20 just to solve. So A equals, and this thing I need to type in. Okay, so 20 times the cosine of 70. Okay, so I'm going to type in 20 times the cosine of 70. Now, right about now, you really need to be asking yourself, before I hit that enter button, am I in the right mode? Okay, so I'm going to hit the enter button just to see what happens. 6.84. Now, I'm going to pop back over and just see 6.84 actually sounds kind of reasonable for this. It's definitely smaller than 20, so it might have worked. And I'm going to look at the mode, and I'm in degree mode. Okay, so that works awesome. So I really need you to think, you know, for one, you need to constantly remember about mode, especially in here right now, because we're going to be working in radians, we're going to be working in degrees, we're going to be popping back and forth. Okay, so please, please, please kind of pay attention to what mode you're in. Okay, 6.8404, 6.840 we'll call that. Okay, so A is 6.840. I think that's what I just said. I'm going to double check because I've been having some issues lately. Cool. All right, so A is 6.840 if I do my 3 decimal places. And that first one was in inches, so I'll say inches there. Okay. All right, I got one more to go. Now, let me say this. You can use Pythagorean theorem to get the third side, but I would like to encourage you, remember that this number is rounded. So if you're going to use Pythagorean theorem, you really need to go back to that whole thing. Now, me personally, I'm not going to do it. Instead, I'm going to come over here and I'm looking at B, and B is opposite. Well, that's opposite. I'm going back to my original, which had hypotenuse, so that's this. So I'm going to do sine of 70 equals opposite over hypotenuse. Now, how did I know it was sine? Because this was the side I wanted, this I knew, and this I knew. So based on what I know and what I want to know, I picked sine because that's what opposite over hypotenuse was. Okay, so I'm going to multiply both sides by 20. So 20 times the sine of 70, and we'll just type that bad boy in. 20 sine of 70 looks kind of similar to what I had typed before. So 18.794. 18.794. 18.794. Again, this is inches. Okay. All right, well, that's it for that example. Okay. And so just to encourage you, the whole idea is, what do you know? What do you want to know? And then choose the correct trig ratio. Sometimes you will use the Pythagorean theorem, not ration, sorry. Sometimes you will use the Pythagorean theorem, just don't use rounded answers to find other answers. Use a lot of answer. Okay, so there's nothing wrong with that. You just need to be aware of it. Okay, quick little note, and then we're going to do a word problem, and then we'll be done. Okay. Sometimes these word problems say things like, okay, these word problems like we've been talking about them all along. Okay, have a lovely boat, and I have an observer up here looking at the boat. And the observer might say something like, look, I see a boat at an angle of depression. Okay, so this would be an angle of depression because the natural inclination is to look horizontal. Okay, so horizontal is left to right, vertical is up and down. The natural inclination, not that, the natural inclination for a human when standing or sitting is to look horizontally. Okay, so that's the natural. And then if you're going to look down, you have to depress your view. Angle of depression is always from the horizontal. From horizontal. It's never with the vertical. It's not that. Okay. Similarly, there could be a little guy in the boat, or no, it's a girl. There it is. And she's looking up, and she has to elevate her view. Okay, so if she has to elevate her view from the horizontal, that is an angle of elevation. Now, because of geometry issues, two parallel lines cut by a transversal alternate interior angles happen to be congruent, assuming those are both horizontal. So those angles happen to be the same, but please note they are not the same as this angle made with the cliff that this guy's looking down from, or something like that. Okay, so angle of depression, angle of elevation are always from the horizontal. That's a big deal. Okay, because usually a lot of times these problems, it's words. It's Susie was looking at an angle of depression from the roof of the building and saw down below a bunny, or something, something like that. And you need to know the angle of depression is from the horizontal, or the angle of elevation is from the horizontal. Okay. All right. Let's do one example. All right. So our question is, and living in the area we are living in, there are a number of television stations nearby, so you should be able to follow this a little bit. We have a 250-foot tower. Okay, so we're saying the height of the tower is 250 feet. Okay, and those towers always have wires that support them, a guy wire. And what we're saying is that for one of those wires, I want to know how long one of those wires needs to be. And I'm telling you that we're going to make it at an 80-degree angle of elevation. Now, just a reminder that the angle of elevation has to be from the horizontal. So this is not it, not this one, because that angle is with the vertical. Okay, so the 80 degrees has to be down here at the ground in this case. Okay, and so the focus needs to be on this triangle. We're going to make an assumption here, this is very common, that the ground is horizontal and the tower is vertical, and so that makes a right angle. So our question is, how long is this wire? Okay, now I know I didn't put a lot of verbiage up there because in interest of time, but that's the gist of it. Okay, so really this problem is like a solve the triangle problem, only instead of solving for everything, you just have to solve for one thing. So you have to correctly identify what part of this triangle are we looking at, and so this is the hypotenuse. This side over here is the 250. That's the side we know. This is the angle. So again, here's 80. Here's 250. We want to know this. Okay, and that's a right angle. That's a beautiful triangle, Mr. Sanford. Thank you very much. So this side is opposite the 80-degree angle. This is hypotenuse. So as I think about my trig ratios, the only one that has both opposite and hypotenuse is sine. So that's what we're going to do. Sine of 80 degrees equals opposite over hypotenuse, and we have to solve. Now, quick little note here. Dividing by 250 does not solve this for x. If I divide by 250, I get 1 over x, because that x is in the denominator. So that is not what I want. What I do need is to get x out of the denominator. Okay, so now I have, there we go, x times the sine of 80 equals 250. Divide both sides by the sine of 80, because that's just a number now, because we're going to type that bad boy into the calculator. So 250 divided by sine of 80. Okay, so 250 divided by sine of 80. I'm going to close my parentheses. 253.857. 253.857. 253.857. This was originally in feet. That is the height, or the length of wire. Now keep in mind that if we knew we had 3 wires and we were really going to find the length, the total length, then we'd be talking about 700 something, 3 times that. So please watch the wording of the questions. All right, well, this has to be done. Again, another long one, and I'm sorry about that. special right triangles, solving triangles, that's the whole deal. And I appreciate you hanging with me, and Sanford Flip Math, I guess we're out.